Laboratory experiment number 9. Ballistic pendulum. Objective. The activity aims to verify the law of conservation of momentum and energy in an elastic collision. Materials: 1 unit laptop, 1 set of rotary motion sensor with USB link, 1 set ballistic pendulum accessory, 1 piece digital adapter, 1 piece long steel rod, 1 piece ruler, 1 set of projectile launcher, 2 units of photo gates. Procedure: set up the apparatus and data studio. Using the photo gates, fire the ball 3 times to get the average speed of the ball to be used as the comparison value for the launch speed. Place the ball into the catcher. Place the pendulum with the pendulum shaft perpendicular to the edge and the counterweight hanging over the edge of the table. Push the pendulum out until it balances and the point will be the center of mass. Measure the distance from the center of rotation to the center of mass. Remove the ball from the catcher. Measure the mass of the pendulum without the ball and with the ball itself. Load the launcher and push the ball in the 3rd fastest position. Start data collection. Launch the ball and it should be caught in the pendulum. After the pendulum has swung and back, stop data collection. Note: the maximum angular displacement measured by the RMS. Repeat step 6 several times. Calculate the average maximum displacement. The value of your maximum displacement, the distance should be used in the equation below to calculate the maximum height that the center of mass rises as the pendulum swings up. Here is the equation. The equation on the screen and the maximum value of height will be used to calculate the launch velocity of the ball. Calculate the percent difference of launch speed found using photo gates and ballistic pendulum. Here are the data and results. Observations: the distance of the ball from the catcher affects the height of the pendulum. The shorter the distance, the lower the height attained. The longer the distance, the higher the height is attained. To get the true angle in each trial, you need to look for the higher maximum angle data record because it shows the angle where the pendulum reaches the maximum height. The mass of the ball affects the height that can be attained by the pendulum because the heavier the ball, the longer the distance for the pendulum to attain the maximum height. Also, the mass of the pendulum affects. Conclusion: in conservation of momentum, when 2 objects collide, the momentum is conserved. During the experiment, when the ball was caught by the pendulum, the collision is called inelastic collision. And in an inelastic collision, 2 objects stick together, and when it happens, the greatest loss of kinetic energy occurs, which is called completely inelastic collision. The percent error falls under 10% of margin of error. That means the objective is attained and verified, but the accuracy is affected due to external force.